the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Settle down, this is serious. We're talking about the eye. Alright kids, settle down. Today I'll be going over the evolution of the eye. First I will make an analogy about how evolution works, and then I'll get going. It is truly remarkable how complex and beautiful our eyes are. It almost feels impossible to imagine how our organ with many components could occur in life. To properly explain, let's go to the drawing board. Imagine two cave people. One of them has a large stick, and the other has no stick. The one who has a large stick is able to kill and eat animals. Meanwhile, the non-stick owner starves to death because he can't kill or eat food. The cave person who had a stick lives on and is able to have babies and reproduce. These offspring share his gene, and so most of them become stick owners as well. Meanwhile, the non-stick owner all die alone without making any babies. This is sort of how evolution works. Who originally had or didn't have a stick was completely random, but because their environment favored stick owners, lived on, and the others died. In the world of evolution, a random feature such as this would be caused by mutation. You see, when reproduction happens, sometimes the offspring can exhibit features that differ from their parents, or even the rest of their species. These mutations can be good, bad, or nothing at all will happen. Because of this, we say evolution is non-goal oriented. Rather, the change that evolution causes is due to a specific need of the environment. If there are two fish, the one that is born with features that allow them to hide better from prey, and is more likely to live on and reproduce. Now that we've covered some of this stuff, let's talk about how evolution gave us the powerful eye that we have today. Let's jump forward 500 million years. See that thing? It's called the euglena. If you look closely, you can see this spot right by the flagella. This is an eye spot. That allowed them to detect light so they can do photosynthesis. This spot was to the euglena what the large stick was to the caveman. A feature that appeared completely random, but was so useful that it allowed anything that had it to reproduce more frequently and pass on its genes. This resulted in more organisms having this eye spot. Now that you've seen this, let's see where a few million years of random changes in evolution brings us. Zoom! See this little cute guy? That's a planaria. If you look at its head, it almost seems to have little eyes. While this isn't quite the case yet, they are close into resembling what we know as eyes today. These spots are now cupped rather than being flat. This is useful because not only can a planaria detect light, but now they can detect where the light is coming from. This allows them to not only locate food, but also hide from predators. Over the millennia, these cupped forms occurred in more organisms, and because it's evolution, something that happened was that these eye cups would appear differently from time to time. Some of these eye cups got deeper at the base with smaller openings. This improved the clarity in which light could be detected. This was called the pinhole effect. Now I'll bring in my assistant to talk about how the pinhole effect was useful.
Hello kids. So you can essentially imagine a ray of light coming in through this tiny hole and reaching a point at the back that is called the retina. And because of this curvature, it allowed detection of direction, which essentially means that they could tell where the light was coming from. And because of the decreased size of the hole in which it was coming from, it improved the optical power even more.
And also, because of this useful improvement upon these eye cups that we have today, it allowed them to see different shapes and allowed them to know, and this small opening that we see right here is where we see the people as we know the people today. The back of the cups became known as the retina. This was the curved part of the eye. where light would focus in on a specific location. On this retina, there are what we call photoreceptor cells. These essentially process the light rays which come in through other people. As his eye cup evolved further, the cup closed more, making the pupil even smaller. The next feature was the lens that covered the small opening and allowed the cups to become full of fluid. This gave the eye maximum optical power. Well, we have now reached the point of complexity that our eyes are now at. It may seem complicated, but just the key components: lens, pupil, photoreceptor cells, and retina. While the eyes is a structure of stunning complexity, the signs of evolution can be seen all over. For example, our human eyes are very flawed in structure. This is because the eyes, like any other organism, evolved as a unit rather than as piece by piece. Going back to the retina discussed earlier, for humans, our photoreceptor cells are actually backwards. To explain the problems that this can cause, imagine trying to speak into the wrong end of the microphone. Sure, it'll pick up some sound, but not nearly the best way possible. The reason for these flaws is because even though a mutation can be detrimental, so long as it does not fundamentally stop them from reproducing, it has a decent chance of sticking around. Evolution of the eye is something that just happened once. It's not just something that happened once. It actually evolved multiple times, and this is something that we refer to as independent evolution. To help me explain this, I'm going to have one of my fabulous students help me try to explain it. Come here, Nick.
Hi.
Hi.
So what am I looking at here?
You're looking at a cladogram. This helps show the evolution and how different animals and species branched off from each other. So see,
Okay.
This is the common ancestor, and this is how different traits and how different traits and how they evolved.
So basically, when you're here, this is the furthest back in time.
Yeah. So just consider that
And then
how.
this is as it goes up, it's progressing in time, and the ones on the top are present-day species, you could say.
Consider this is where the eye spots are created. Now, to describe how independence works, you have to think of this is the octopus and this is the humans. They all they developed the eye spot, but the way that they developed their own eyes was independently. They didn't work independently.
Okay, so basically,
We just didn't inherit our eyes from octopus.
so these two species, they aren't related.
They are
because
not related.
The chain in their family line essentially ends once this thing splits
Yeah,
out.
the only relationship they bear is the eye spots way back here. After that, each species underwent its own evolutionary process, adapting to whatever environments they required. Millions of years later, we have the species that exist now, with their own eyes that evolved independently. Did you know, Nick, that eyes evolved independently 50 to 100 times?
Wow.
Yeah, that's incredible. If you think in terms of one small improvement after another over the course of hundreds of millions of years, it becomes clear of how something even this complex could be created. Now that you've learned about the evolution of the eye, now I'm going to ask the class a few questions. Alright, when did the eyes first start to evolve? Nick!
500 million years ago.
Correct! No wonder you're such a good student. My next question is, what was the earliest form of the eye? Anybody? Anybody? Ugh, Nick again?
It was the light spot on the euglena.
Wow. Yeah, you got this. Alright, how did the eye spots help the euglena? Anybody? And other than Nick? No? What's the answer? Alright, Nick, what's the answer?
It helped the euglena reach areas where there was more light, so then the chloroplast could photosynthesize.
Are none of you guys paying attention? Is Nick the only one that was even here to pay attention? How many times did the eyes develop independently? Anyone?
50 to 100 times.
Alright, next question. Why would an octopus's eye be different from our own eye? Anybody? You, Billy.
It's because the octopuses used the features more that were good for the octopuses, but we used the human features of the eye more, so then we evolved those instead.
Sorry, Billy. You got the environment part right, but evolution does not deal with usage, but rather they simply adapt to their environment, sometimes through random changes, sometimes because of features most desired by mates.
Yeah.
For the final question, I'll be asking, why are eyes so important? Nick?
Well, you see, eyes are important because generally organisms need to use it to seek food or to hide from predators.
Wrong. You need your eyes to see the awesome ending of this PowerPoint. And another special thanks to one of our that helped make some of these awesome animations is Michael Smalls. He also helped record this video. And I want to say a special thanks for watching it. Thank you.
No? Thank you.
Science rules.